Jupiter, with a colossal diameter of nearly 140,000 kilometers, reigns as the largest planet in our solar system. This giant is so vast that Earth could theoretically fit into it over 1,300 times. Furthermore, Jupiter's mass is about 2.5 times that of all the other 7 planets combined. Surprisingly, despite its massive size, Jupiter is the fastest rotating planet, completing a rotation in just under 10 hours. Aside from its immense size and speed, Jupiter boasts a landscape of gigantic storms and perilous radiation. One of its most famous features, the Great Red Spot, is larger than Earth itself and boasts wind speeds reaching up to 680 kilometers per hour. But what mysteries lie hidden beneath Jupiter's dense cloud bands? And how did this planetary giant play a role in Earth's very existence? Jupiter's formation story is as dramatic as its appearance. Researchers from the University of Munster recently succeeded in determining Jupiter's age by studying meteorites, as the gas giant has no solid surface for direct sample collection. They found that Jupiter grew to 20 Earth masses within 1 million years of the solar system's formation, completing its development in just 3 million years. For comparison, Earth took about 100 million years to reach its current form. As the largest and oldest planet in our solar system, Jupiter formed from the residual dust and gas left after the Sun's creation 4.6 billion years ago. Composed primarily of hydrogen and helium, like the Sun, Jupiter's main density is relatively low at 1,330 kilograms per cubic meter. Despite their shared composition, Jupiter orbits far from the Sun, about 778 million kilometers away, situated between Mars and Saturn. Interestingly, Jupiter doesn't technically orbit the Sun directly. Instead, it orbits a point in space called the barycenter, which is the center of mass between two celestial bodies. Due to Jupiter's significant mass, this barycenter lies just outside the Sun's surface, creating a unique orbital relationship that hints at the gravitational impact Jupiter has on our solar system. Jupiter's gravitational force doesn't only affect the Sun, it also significantly influences its surroundings. The planet currently has 95 known moons under its gravitational hold. One of these moons, Europa, is suspected of harboring a subglacial ocean where extraterrestrial life may exist. However, more research is needed to confirm this possibility. Probes have long been exploring the Jupiter system, and NASA's Juno probe continues this mission today. The European Space Agency's JUICE mission is also en route to Jupiter, having launched in 2023 and expected to arrive by 2031. These missions aim to unlock more secrets about this gas giant and its moons. Jupiter's gravitational strength is about 2.5 times that of Earth, and its massive gravitational field acts as a shield, deflecting potentially dangerous comets and asteroids from Earth. However, this gravitational force can also have destructive effects, as some studies suggest that gas giants like Jupiter can eject smaller planets from their habitable zones. Jupiter's turbulent past may have included a journey through the solar system. Researchers suggest it may have initially formed far from the Sun before moving inward, dragging planetary building blocks and debris along with it. This migration stirred up collisions and chaos, thinning the inner solar system and creating conditions that eventually allowed Earth to form. Jupiter's presence also explains a unique aspect of our solar system. In most other planetary systems, large gas giants or super-Earths orbit very close to their stars. In contrast, the inner planets of our solar system formed farther out and contain relatively little gas, a setup that may have been enabled by Jupiter's early influence. Visually, Jupiter's iconic cloud bands are instantly recognizable, ranging in color from white to blue. These bands consist of alternating zones and belts, with lighter zones containing rising gases likely made of ammonia ice. The darker belts, whose composition remains uncertain, may contain phosphorus, sulfur, or hydrocarbons. Researchers have observed a cyclic color change in these bands every 4 to 5 years, possibly linked to Jupiter's magnetic field. The boundaries of these cloud bands are defined by powerful jet streams, with wind speeds reaching 300 kilometers per hour. However, these winds pale in comparison to those in the Great Red Spot, the solar system's largest storm, where speeds can reach up to 680 kilometers per hour. This massive anticyclone, first observed in the 19th century, has shrunk over time, now measuring about 16,500 kilometers in diameter, down from 40,000 kilometers in the 1880s. Despite its age and size reduction, the Great Red Spot remains active and dynamic. Recent observations from the Hubble Space Telescope show that it oscillates in size and brightness as it migrates east to west. Its eye is at its largest and brightest when moving the slowest, and in time-lapse, it appears to shake due to interactions with the surrounding jet streams. Scientists are still investigating whether the Great Red Spot will one day disappear entirely. They're studying whether there's a minimum size beyond which the storm might become unstable. The interplay between the Great Red Spot and Jupiter's atmospheric forces provides an ongoing opportunity for researchers to better understand this fascinating planetary phenomenon. Jupiter's formation, evolution, and complex dynamics highlight its role as a protector, disruptor, and one of the most enigmatic celestial bodies in our solar system. The gas giant continues to captivate us with its mysteries, and new discoveries await as probes explore this vast world and its many moons. As we delve deeper into Jupiter's formation and evolution, we see it wasn't merely a bystander in the solar system's early development, but a true shaper of its structure. Its early migration within the solar nebula, likely due to gravitational interactions with the surrounding gas and dust, disrupted many young planetary bodies. This movement caused a dramatic reshuffling of materials, scattering smaller planetesimals and leading to the formation of terrestrial planets, like Earth, in the Sun's inner orbit. If not for Jupiter's gravitational influence, these rocky planets might have accumulated excess gas and developed as super-Earths rather than the smaller, rocky worlds we know today. This early chaos likely also prevented the formation of planets similar to Jupiter in the inner regions of our solar system, an anomaly when compared to exoplanetary systems with close-orbiting gas giants. Another fascinating aspect of Jupiter's presence is its role as a cosmic shield for Earth and the inner planets. While Jupiter's immense gravity can deflect asteroids and comets, preventing frequent collisions with Earth, it can also alter the orbits of these objects, sometimes sending them inward toward the Sun. In fact, Jupiter's influence on the asteroid belt, located between its orbit and Mars, ensures a constant supply of rocky debris that occasionally crosses Earth's path. Scientists believe that some of these impacts brought essential elements, like water and organic molecules, to early Earth, which might have contributed to the conditions necessary for life. This balancing act of protection and potential danger underscores Jupiter's complex role in both safeguarding and shaping life on Earth. Aside from its impact on Earth, Jupiter's moons offer tantalizing insights into the potential for life beyond our planet. Europa, in particular, is a key focus because of its subglacial ocean, which might be warmed by tidal forces from Jupiter's gravity. This heating could create an environment where microbial life could exist, protected beneath the icy crust. Upcoming missions, such as NASA's Europa Clipper, aim to study the composition and potential habitability of this ocean in detail. Other moons, like Ganymede and Callisto, also have icy surfaces with potential subsurface oceans. These moons, with their diverse environments, represent some of the best places to search for signs of life in the outer solar system, adding another layer of intrigue to the Jovian system. Scientifically, Jupiter has been a frequent subject of observation and exploration, beginning with early telescopic observations and continuing with modern-day space probes. The Juno mission, launched by NASA in 2011, has provided unparalleled insights into Jupiter's atmosphere, magnetic field, and internal structure. Juno's data revealed surprising details, such as the presence of a deep, dense core and strong magnetic storms near the poles. These findings challenge previous assumptions and suggest that Jupiter's formation and evolution are more complex than initially thought. The ESA's JUICE mission, expected to arrive in 2031, will extend our knowledge by focusing on Jupiter's icy moons, which adds another layer of complexity to our understanding of the gas giant and its impact on surrounding celestial bodies. Ultimately, Jupiter's mysteries are far from fully unraveled. Its turbulent atmosphere, extreme radiation belts, and diverse moon system make it a constant focus for scientific inquiry. The ongoing research into Jupiter's Great Red Spot, cloud bands, and internal structure continues to inspire questions about the atmospheric processes on other planets, including our own. As our observational technology improves, we may soon unlock even more answers about Jupiter's deep history, its influence on the solar system, and the possibilities for life in environments far different from those on Earth. Each new mission to Jupiter brings us closer to understanding not only this king of planets, but also the broader dynamics that shape planetary systems across the universe. Jupiter's mysteries are endless, from its massive storms to hidden oceans on its moons. At Spacelab, we're here to bring you the latest in cosmic discoveries. If you're as curious as we are, hit subscribe and join us on this journey through the universe. Thanks for watching.